All right, here are solutions to the first perfect problem of this quarter. What's this, Math 251? On this problem, we're given, I guess we have two problems here. Evaluating some limits. It says don't use a calculator. Okay. This first one, x to the 16th power minus 1. So I want the limit as x approaches 1 of x to the 16th power, kind of ridiculous, minus 1 over x minus 1. It'd be really nice if I could just change all the x's into 1s. Right, make this 1 to the 16th power, make this 1 minus 1. The problem is, if you did that, if you tried to evaluate this limit by changing all the x's into 1s, you get 0 divided by 0. You wouldn't get any information out of this thing. It would be undefined. So what you have to do is rewrite this limit in an equivalent form until we get it to a point where we can change all the x's into 1. The way you do that in this specific case, maybe I'll switch colors, is you're going to have to factor. So let's factor this x to the 16th minus 1. You might notice it's a difference of squares. Right? X to the 16th is a perfect square. It's x to the 8th power times x to the 8th power. Similarly, 1 is a perfect square. It's 1 times 1. And so anytime I have a difference of perfect squares, it factors into this form where you get these conjugate pairs, x to the 8th plus 1 and x to the 8th minus 1. We're not done here. This one's done. We can't factor this any further, but this one's still a difference of squares. So that's equal to x to the 8th plus 1. See, as a difference of squares, this would factor to x to the 4th plus 1 times x to the 4th minus 1. Guess what? Another difference of squares. Can't do anything with x to the 8th plus 1. Can't do anything with x to the 4th plus 1. But x to the 4th minus 1 is a difference of squares, so it factors to x squared plus 1, x squared minus 1. Done? Nope. But almost. Again, can't do anything with these first few terms, because they're not differences of squares, they're actually sums of squares. But the last one, x squared minus 1, that's x plus 1 times x minus 1. Anyways, this mess right here factors into this. It turns out that the limit as x approaches 1 of x to the 16th minus 1 over x minus 1 is the same as the limit as x approaches 1 of this thing. I don't want to rewrite it, but I will. X to the 8th plus 1, x to the 4th plus 1, x squared plus 1, x plus 1, x minus 1. It's that entire mess over x minus 1. This is where we're going to cancel out the x minus 1s. Be a little bit careful. This thing written here is, you can't just cancel out the x minus 1s in that thing. But because I have the limit as x approaches 1 out in front, I am able to cancel out this x minus 1 and this x minus 1. What I'm getting at is this limit is equal to the limit as x approaches 1 of x to the 8th plus 1 times x to the 4th plus 1 times x squared plus 1 times x plus 1. So I cancel out this and this. This is now a limit I can evaluate. I couldn't evaluate this one because I tried changing all the x's into 1s, and I got 0 over 0. Damn. But I can evaluate this limit here. I can change all the x's into 1s, and I won't get 0 over 0. I'd get, what, 1 to the 8th power plus 1, whatever that's equal to, times 1 to the 4th power plus 1, times 1 squared plus 1, times 1 plus 1. Let's see, 1 to the 8th power is 1 times 1 times 1, blah, 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 8 times. That's just 1. 1 plus 1 sounds like 2. 1 to the 4th power, 1 times 1 times 1 times 1 is 1. 1 plus 1 is 2. Probably see the pattern that's going on here. All 4 of these factors are just equal to 2. 2 times 2 times 2 times 2 is equal to 16, which is what this limit is equal to. Okay, the next one. The ridiculous absolute value problem. So what am I doing? Another limit as x approaches 1. This time the limit that I'm evaluating is x minus the absolute value of x minus 1 divided by x minus 1 divided by the absolute value of x minus 1. Wow. Okay, that's a little bit overwhelming if you look at it. Fortunately, we have a method for dealing with these. And the method is whenever you see absolute value symbols, you take this two-sided limit and break it up into two different one-sided limits. What I'm saying is instead of figuring out the limit as x approaches 1 of this giant mess, figure out the limit as x approaches 1 from the negative side of this entire mess. The worst part about doing these problems is having to recopy them in all of these steps. Maybe not the worst part, but an annoying part. The limit as x approaches 1 from the negative side of this thing, and then the limit as x approaches 1 from the positive side of this thing. Might seem like I haven't made things any easier. I took one hard problem and made two hard problems. Turns out these problems are easier than this problem because we can start getting rid of absolute value symbols. The limit as x approaches 1 from the negative side. So the way you have to think about this is x is taking on some value close to 1, but a little bit less than it. Whereas over here, x is taking on some value close to 1, but a little bit more than it. And so that subtle difference of being a little bit less than 1 or a little bit more than 1 will be what we have to look at when we determine the sign of the things inside the absolute values. Because if I'm taking the absolute value, this might be unnecessary, of a positive number, the absolute value of 7, that's just 7. Anytime you have the absolute value of something that's positive, you don't even need to write the absolute value symbols. You can just get rid of them. However, if you're taking the absolute value of something that's negative, negative 7 for example, you can't just drop the absolute value symbols. This is not equal to negative 7. It's actually equal to positive 7. So how do I get from here to here? Well, one way of getting there is saying this thing, negative 7, those are supposed to be parentheses. If I'm going to get rid of the absolute value symbols, I have to do what the absolute value symbols would do. Well, what would they do? If it was negative, it would change it to a positive. Mathematically, the way you can express that is you can say it takes the thing on the inside and multiplies it by negative 1. So this negative 7 right here gets multiplied by negative 1. Negative 7 is positive 7. I know you never think about absolute value symbols that way. You just say, oh, it's just 7. But mathematically, this is what's going on. It's taking this thing inside and multiplying it by negative 1 if that thing inside is negative. That's the way we're going to think about these problems. So I'm going to erase that mess that I just did, but apply that logic over here. If x is a little bit less than 1, these right here, this x minus 1 inside these absolute value symbols, x is a little bit less than 1. If x is a little bit less than 1, something a little bit less than 1 minus 1 is a negative number, right? 0.99999 minus 1 is a negative number. It's a negative number that's really, really small. It's close to 0, but it's negative. That's the key point. Well, if it's negative, I can't just get rid of these absolute value symbols. If it were positive, I could just get rid of the absolute value symbols, but it's not. It's negative. So I can't just get rid of the absolute value symbols. I have to think about what the absolute value symbols do. And like I did in my stupid little example over here, what they do, if you're going to get rid of these absolute value symbols, what they do is they're going to change the sign. Here's mathematically change the sign of. We'll leave everything else the same. What you'll see is that now inside these absolute value symbols, I can cancel out the x minus 1s. Can't just cancel them out, but because I have the word limit written here, I'm allowed to. These x minus 1s cancel out, and I'm just left with negative 1. So what this is saying is the limit as x approaches 1 from the negative side of x minus the absolute value of negative 1 divided by the absolute value of x minus 1. The absolute value, where am I going to go here? I can do this, of negative 1 is just positive 1. So this is really just saying the limit as x approaches 1 from the negative side of x minus the absolute value of negative 1, 1, divided by the absolute value of x minus 1. I'm almost done. I've reduced this thing. I've gotten rid of a lot of the absolute value symbols. I just have one left down here on the bottom. If x is a little bit less than 1, this is a little less than 1. A little less than 1 minus 1, it's a negative number. If I'm going to get rid of the absolute value symbols, I have to think about what they do. And what they would do is they would change that thing down on the bottom, the sign of it. In other words, I'll put a negative out in front. You get here. Cancel out those x minus 1s one more time, and what I get is it's the limit as x approaches 1 from the negative side of negative 1. The limit as x approaches 1 from the negative side of negative 1 is just equal to negative 1. Why is that true? Because the way you evaluate limits is you change all the x's into whatever this number is. There are no x's, so I've changed all the x's. I've changed none of them into what it is. All I'm left with is negative 1. It's not my answer. That's the answer to this one-sided limit. This one-sided limit, I get negative 1. I'm going to do that whole thing over again. If I get the same answer, then that will be the answer to the question. If I get a different answer, I'll know that the answer to the question is undefined. So let's do that again, maybe a little bit quicker. The limit as x approaches 1 from the positive side. Now x is greater than 0. I'm going to take care of these absolute value symbols first. X is a little bit greater than 1, not greater than 0. X is a little greater than 1, something a little bit bigger than 1, 1.0001. Minus 1 is a small number, but it's a small positive number. Absolute value symbols don't do anything to positive numbers. I can drop these absolute value symbols without changing anything. I get here. I get here. Okay, take it a step further. Limit as x approaches 1 from the positive side of x minus 1 over x minus 1. Those cancel out. Just equal to 1 here. So I have x minus the absolute value of 1 over the absolute value of x minus 1. Maybe I take this, if this wasn't hard enough to follow already. Absolute value of 1 is just 1. So this is the limit as x approaches 1 from the positive side of x minus 1 over the absolute value of x minus 1. One last absolute value symbol to get rid of. See, again, x is a number slightly bigger than 1. Slightly bigger than 1 minus 1 is still positive. If it's positive, the absolute value symbols aren't doing anything. Get here. In other words, the answer to this one-sided limit is the limit as x approaches 1 from the positive side of 1. These cancel out. That limit is equal to 1. What I've gotten are two different answers. What that tells me is that this thing is undefined. That's the answer to the question. A lot of work just to say it's undefined. But there you go. Those are the answers. I guess I'll stop this video here.